All right, we're still in module 2. Welcome to the next micro lecture on primitive data types and typecasting. All right, so what are primitive data types and what is typecasting? Well, primitive data types are predefined by C# and are named using reserved words. Reserved words like int, string, bool, things like that. Please understand that we have spoken about primitive data types in passing and in detail, but I wanted to dedicate a micro lecture just to it. Unlike Java, all primitive data types are objects. So one of the issues with C# is that there are two rules which are completely defined, which define what a primitive data type is. A primitive data type is two things. One is the atomic layer of your language library, right? So your primitive data types cannot derive or inherit anything else. They cannot be a child class to anything else. Primitive data types are just that, primitive, meaning they're the most atomic layer of your data typing. Now, we can create our own custom data types, and we do it all the time when we create classes. But please understand that primitive data types themselves are built in from the system library in C# or the default library in Java. Now, one of the problems that you're going to run into with that specific rule number 1, meaning that all primitive data types do not derive from anything else, is that primitive data types in C# are objects, which means they are derived from the base object class. That defies the whole logic of primitive, but for all intents and purposes, it is not the offshooting of something else if you ignore the object part. The second thing that makes a primitive data type primitive is the fact that you can build off of it. One of the things that primitive data types give you the ability to do is to create other data types out of them. For instance, a char is a primitive data type. A string is not a primitive data type. Now, the reason why strings are not primitive data types is because they are built out of other data types, right? And so that's one of the issues that you're going to run into. A string is a collection or array of chars. Thus, a string cannot be a primitive data type because it is a compilation of something, or it inherits from something. Let me say it again. The two rules are a primitive data type does not derive or inherit from anything, and a primitive data type is not a compilation of anything. It is literally the base atomic structure of the data type. Now, some of the most widely used primitive data types that we have in our programming world, and specifically speaking about C#, are our integral data type, which is integer, object, that is a primitive data type, short, long, double, these are your floating point data types. They allow you to have decimal points. Char, which is basically based on the Unicode library or dictionary, if you will, of hexadecimal base 16 numerical values that allow us to use symbols or characters when we type or when we want to communicate with our computer. So for instance, the A is representative of a hexadecimal base 16 value that is specific to your keyboard. If you had a Spanish keyboard or a keyboard that was Espanol driven, you would have the tilde, and that also has a specific hexadecimal base 16 output, if you will, so the computer knows what you're doing. So with that being said, let's talk about typecasting. What is typecasting? Typecasting is the act of assigning a value of one data type to another data type. You can call this conversion, right? There may be a situation where you want to convert from an int to a string. Maybe you want to print in the console.write. So you're going to convert the int to a string, or vice versa. Whatever you're trying to do, normally the method you're trying to feed the data to may require you to define the data type that thing is, that variable is. Now, or redefine it. Now, there are two types of casting, and there's something I want to talk about with casting too. Casting is not converting. Those are not the same thing. So let me explain what casting is, right? So casting is the ability to take a value, assign that value to a new variable or an old one, doesn't matter, with a different data type. However, wherever that specific value was to begin with never changed. It's kind of like taking like a bottle, okay, and you are giving that bottle to storage, But when you give it to storage, you're copying it into storage, right? And you're painting it when it goes over there. But the bottle itself that you have is still the same. The copy is what changed. And the same thing happens when you cast, right? You're casting a copy of the data type and value to a new variable and or the same variable, doesn't matter, right? Depends on if the variable is dynamic or not, the type of the variable is dynamic or not, and you're assigning it a new type. This is it sounds very complex when I explain it, but when I show you it, it's not that big of a deal. Either way, casting is basically copying the value in the data type over to a new variable and changing the type while you're doing it. There are two types of casting: implicit casting and explicit casting. Now, the opposite of casting, or I'm sorry, the brother or sister to casting, is conversion. And what conversion does is it actually changes the value data type. It changes the data type of the value in the variable instead of copying it to a new variable and changing the data type, even though the variable you copied from stays the same. So conversion is actually changing the value and the data type, or the data type of the value in the variable as it sits in that memory location. Okay, so what's implicit casting? This is somewhat not intuitive, so let's explain, right? Implicit casting is when you do a conversion. I'm sorry, when you cast without knowing you did that. This happens when you use console.writeLine or console.write. If you give console.writeLine an integer, it will implicitly cast it to the appropriate variable. Implicit casting also happens when you're using the keyword var, as I did in module 1. Var allows you to dynamically call the loosely typed data types based on the value being assigned to the variable. This also happens when you are trying to change or save something to something else. Let's say you wanted to save a float or a double to an integer. That would implicitly cast to integer. Now, the problem is that when you do that, you're going to lose your decimal points. Either way, explicit casting is when you cast on purpose. It's when you do it yourself. And the way we cast is quite simple. We use reflection. All right. So this is called reflection, where I'm saying, hey, I have a variable called sum with the data type double that is assigned the value of 9.78. I now want to save that value, 9.78, to subtotal, which is a new variable of integer data type. I'm going to need to cast the sum of 9.78 to the variable of integer, of type integer, of subtotal, named subtotal. Now, subtotal will have an integer of value 9. It will not round up. It'll just cut off the decimal and everything after that, right? But the sum, the variable sum never changed. If you debug this code, the variable sum did not change. It will remain a double of 9.78. You're just casting a copy of it. You're assigning a copy of it to subtotal with a new data type. And understand, when you implicitly or when you explicitly cast from a double to a float, you will lose the decimal points. They will not round up or down. That is not a part of the code, because an integer is a positive or negative whole number. As I said, type conversion is not type casting. Type casting, as I said in the last slide, was taking the actual sum, the variable sum, copying an integer data type of it to a new variable, or the same if you decided you wanted to convert sum altogether. But type conversion is doing it all in the same breath. We're not copying anything out of sum and assigning it to a new variable. What we're actually doing is we're modifying sum. In this case, we're modifying int val. So check it down here, right? Another way to explicitly cast is to type convert. I wrote that wrong. Explicit casting and type conversion are not the same thing. So ignore this slide for a second and understand that type conversion happens one variable. Explicit casting happens with two variables. So I miswrote this, or I wrote this incorrectly. But what I will tell you is, if you look at the code the way it's written, int val equals 10. That means that we have a variable of int val, which is assigned the value of 10. We also have a variable called double val of type double, which is assigned the value of 5.25. And we have a variable named bool val of type data type boolean, which is assigned the value of true. Remember, 1 equal signs equals assignment, and 2 equal signs, right, it equals equality. In this case, these are assigning, right? So when we look down here at lines 4, 5, 6, and 7, what's happening? Well, when we do console.writeLine, something interesting happens. Whatever's in parentheses goes first. We're going to talk about this later on down the road with PIMDAS in this specific module, but understand that convert.toString is a type conversion method built into the system library that you can use when you overload that with the variable and or value you want. It will convert it to a string in this very location. The same with to double, the same with to 32 int. This will change, update to int, and that will update to string as well. You can literally convert almost anything into a string. Literally almost anything. All right. Onwards, I would like to show you what this actually means. So, without further ado, let's do some typecasting. So in this case, we have a string of Francis Fiske. Well, let's do something else. We've been using this one quite a lot. Let's say we had an int of x, and that equals 1. We have an int of y, and that equals 1. And if I said console.writeLine, and I said, whoop, we're going to do some string interpolation. Everything in computer science starts counting at 0. I forgot to say this when we were speaking about string interpolation in the last micro lecture. Everything in computer science starts its count at 0. It's very important that you understand that, because when we get into things that require numerics based on the key of that specific thing, it will always start at 0 if it's numerically numbered. We're going to speak about enumerations later on in another micro lecture in this specific module that'll give you some more context to this. So either way, x, y, x plus y. And just to be safe, we'll make sure that that is encapsulated in a parentheses. Okay, great. So what did I do? Well, I initialized the variable x of data type int as assigned the value of 1. I then did the same thing to an int y equals 1 as well. And then I said, okay, I want you to print whatever the first variable is in this yield, plus whatever the second variable is. This is a string, by the way, so it won't do anything but print characters. And then I said, I want to print x plus y as well as the sum. Let's see what happens. I did not mean to do that. I'm so used to pressing F5 when I want to run something. Let's try to run this. This should console.writeLine 1 plus 1 equals 2. Now, once this does that, then I want to go over what happens when it's taking a while, actually. Oh, that's interesting. You can actually debug in other languages except for C#. That's disappointing. I wanted to debug this for you in REPL, but that's not important. So either way, here we go. We have the printout 1 plus 1 equals 2. Fantastic. So now what I'm going to do, let's do some changes. Let's say I wanted to say 1 equals and then 1.5 equals, and we'll change this to double. I wonder what my outcome is going to be. What happens when I add an integer to a double? Well, I'm going to go off on a hunch and say you get a double, because the computer wants to give you the most specific outcome that you can get. Any day now. I shouldn't have refreshed the screen. That's my fault. There we go. It gave it to us, right? It converted, when you add an int to a double, it converted directly to a double. But what happens when I do that? What happens when I reflect the value 1.5 as an integer into a double? Will I get an error? No, I won't. What will actually happen is the value of 1.5 will be reflected or cast as a 1. And so the answer is 1 plus 1 equals 1 again, but it's going to say, or 1 plus 1 equals 2, just like that. Now notice there's no decimal points. That's because I cast int into double. I'm forcing double to act like an int. This is quite an interesting typecast that I don't normally show off or brag about, but there's one more thing I do want to show you. So we cast this guy, right? But you really don't know that this didn't change. So let's do this for a second. Let's say int y equals 1.5, or I'm sorry, double y, double y. And then we'll say z, we'll say y, right? But I'm gonna do something really cool. We're gonna print y right after this. I want to show you that y didn't change. That's very important. The value of y is. Watch this. Now, like, remember what I said. When you typecast, you're not changing the value or the data type that's in the variable itself. You're reflecting a new data type to the new variable, and the old variable is retaining its old identity. It never changed. Watch this. And as I say that, this doesn't work. Watch. It's just going to prove me wrong, eh? And look, I got smoke coming off of it. Look at that. The value of y is 1.5. Now, something very interesting. I typed 1.5 here, right? And then I said, I would like you to reflect. Maybe it was too close. Maybe I need to put a space between the two. That shouldn't matter, though. I don't think that syntactically would do anything. Notice that when I put 1.5 next to that reflected int, it made it 1 plus 1 equals 2. But when I did it in a variable of a double, it didn't do that. If I wanted to convert y to a something else, I would have to say convert to int 32 or whatnot. Now, here's something very interesting. You don't have to say convert if you want to convert to string. If you want to convert to string, this is all you have to do. Find the thing you want to convert. So in this case, I want to convert the sum of x plus y. I can say dot to string, and that should work just fine. Oh, double doesn't right. Double doesn't contain to string, so you're going to have to use convert. My apologies. It's a primitive data type. Because double is a primitive data type, I have to say convert to int 32 or 16 or 64. Notice there's a bunch of digits and bits I can use. So in this case, 32 is as big as I want to get. Convert, and then that'll convert to a string, or that'll convert to an int. I should say to string instead. And bada bing, bada boom, if I run this, it's not going to change anything. You're not going to really see the difference because it's already being converted to a string in console.writeLine, but this won't fail. And it will spit it out as a string. If I try to save that to a double or an int, it would fail because you can't save a string to a numerical value. You can't save an alphanumeric or a char, my apologies. You cannot save a char or an array of chars to a numeric data type. All right, either way, that's all I have for today. As I say in all my videos, good luck. Have fun.